Hello everyone. Today we are going to talk about addition and subtraction, finding the missing value, adding and subtracting negative fractions, and then the last skill we'll talk about is interpreting negative number statements. So let's start with finding the missing value. So notice that they give you a number line. I can't stress this enough. I would strongly recommend that you utilize this number line while you are doing these problems. So this says -3 equals 7 minus what number? And we're trying to figure out what that number is. So I'm going to look at my problem. I see that 7 is my starting point. So I'm going to plot a point where 7 is. And I see that my ending point, which is my answer, is -3. So I'm also going to plot a point at -3. So I'm starting at 7 and I'm going to the left and ending at -3. Now we know that when we move to the right on a number line, that would be addition. And when we move to the left, it would be subtraction, which we're moving to the left and I can see that they already have subtraction in the problem. So my next step is I just need to count how many units am I moving. So clearly from 7 to 0 is 7 units, and from 0 to -3 is another 3 units. So 7 plus 3 gives me 10, which means I am moving 10 units to the left. So now if I were to take 7 minus 10 and to do keep, change, is that going to leave me with a -3? Yes. And that's how you can check it to make sure you did it correctly. Let's try another one. Notice now that I'm missing my starting point, then they're telling me what to do and giving me the answer. So we don't know where we're starting at. That's going to be the tricky part. All I know is that I'm going to be adding a -4. Well, when you add a negative, which way do you move? It's addition, which means you'd normally move to the right, but you're adding a negative, which means you're going to be moving to the left. Now notice your ending point here is a -1. So let's plot a point at -1. And I know that to get to that -1, I'm going to have to move 4 units from somewhere to the left. So that means that to find our starting point, we just need to do the opposite and move 4 units to the right. So I'm going to count 4 units, 1, 2, 3, 4, which would make my starting point right here, which is a +3. So let's try that. So if I were at +3 and I added 4 negatives, I'd move to the left 4 units getting to -1. Is 3 plus -4 going to leave me with a -1? Well, our rule says different signs we subtract and keep the sign of which has more, which we clearly have more negatives. So 3 would be the correct answer for this one. Let's try another one. So we know our ending point is -4. So let's plot a point there. I don't know my starting point. That's what we're trying to find. But I do know that to get to my ending point, I'm subtracting 9 units. So we're going to do the opposite. So instead of subtracting 9, I'm going to take my ending point and I'm going to add 9. So let's count 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So that means that my starting point was a +5. So let's plug that in and check it. If I were to do 5 minus 9 and I do keep, change, does that leave me with a -4? Yes, it does. Different sign, so we subtract and we have more negatives than positives. Okay, moving on to, whoop, I think I had one more problem here. There we go. All right, so here we've got -3 equals blank minus 11. Again, we're missing the starting point, but we know that our ending point's at -3. So let's plot a point there. And I can see that I'm subtracting 11 from my starting point. So we want to do the opposite. We're going to go -11 would mean going 11 units to the left from your starting point. Since we're trying to find that, we're going to go 11 to the right. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That should put us right around here, which looks like it's at 8. So let's check it out. Is 8 minus 11 going to give me a -3? Well, keep, change, different sign, so we subtract, and I have more negatives than positives. So the correct answer here would be 8. Okay, moving along to adding and subtracting negative fractions. I think it's important that we talk about some vocabulary before we get into this. So far, we've been dealing with just integers, which, as you can recall, integers are whole numbers and they're opposites on the negative side, which are all rational numbers. Rational numbers are also fractions, decimals, and percentages. A rational number is any number that can be expressed as a fraction. So we're basically moving on from integers to rational numbers now. Fractions, decimals, percentages. This next slide shows a Venn diagram just to kind of give you a clearer picture of where numbers fall. So right here in the middle, you've got your whole numbers. Those are all going to be positive. And we've got 1, 3, and 35 there as examples. Integers would be include your whole numbers. That's why this is inside your integer circle as well. So it would be whole numbers and their opposites. So for example, you've got 3 and negative 3, 35 and negative 35. 35 would be a whole number, but negative 35 would only be an integer, not a whole number, because it's a negative. And then out here on the outside, we have all of our rational numbers, which include whole numbers, integers, as well as your percentages, your decimals, your fractions, your terminating decimals, and your repeating decimals. Okay, so let's get into a few of these addition and subtraction problems. So hopefully we remember from 5th and 6th grade that when we add and subtract fractions, we always have to find a common denominator. So here I have negative 3/7 plus negative 3/4. So the first thing I'm going to do is find my common denominator. I'm going to start with my bigger number, which is 7, and I'm going to go through my multiples. Clearly 4 doesn't go into 7. Next would be 14, which 4 doesn't go into. Then we've got 21, which doesn't work. 7 times 4 is 28. There we go. That's going to be your common denominator. So I'm going to write equivalent fractions on the bottom. Notice I'm leaving my negatives there so I don't forget about them. And then we need to ask ourselves, what am I multiplying 7 by to get to 28? Well, I'm multiplying by 4, and whatever we do on the bottom, we do to the top. So my equivalent fraction is going to be negative 12 over 28. And then here, to get from 4 to 28, we're multiplying by 7, and whatever we do on the bottom, we do to the top. Now we're going to follow the same rules that we've been using all along. I have same signs, so I'm going to add and keep my sign. Now remember, when we add fractions, the denominator stays the same, and our numerator is what we add. I'm going to keep my negative. 21 plus 12 is going to give me negative 33 over 28. And your last step is to always ask yourself, is there any way to simplify this improper fraction that I have? And no, there is not. 33 and 28 share no common factors. So your final answer here would be negative 33 over 28. Let's try another one. Okay, so here our denominators are 8 and 6. So let's look at our multiples of 8. We've got 8, 16, 24. So 24 is going to be your common denominator. So let's start getting our equivalent fractions ready. Okay, I do notice subtraction here. We know our rule for subtraction is to keep change change. So I'm just going to switch those to addition and to a positive. And then we're going to make our equivalent fractions. To get from 8 to 24, we're multiplying by 3. Whatever we do to the bottom, we do to the top. So that's going to leave me with a negative 21. And then over here, we're multiplying through by 4. And that's going to leave me with a negative 20 on the top. But we also did keep change change. So that became plus positive 20 over 24. So now I'm solving negative 21 over 24 plus 20 over 24. I have different signs, which means that we're going to subtract, and we have more negatives than positives. My denominator stays the same. We have more negatives than positives, and 21 minus 20 gives me a 1 when I subtract it. So your final simplified answer would be negative 1 over 24. Let's try another one. Okay, so our denominators are 9 and 12. So let's use 12 and go through its multiples to find our common denominator. Obviously 9 doesn't go into 12, 9 doesn't go into 24, 9 does go into 36, so 36 will be our common denominator. Let's go ahead and set up our equivalent fractions. To get from 9 to 36, we're multiplying through by 4. What we do on the bottom, we do to the top. So that leaves me with negative 20 over 36. And then over here, we're multiplying through by 3. So that's going to leave me with a negative 21 on the top. Same signs, so we're going to add and keep our signs. So that's a negative 20 plus 21 is 41 over 36. And 41 is actually a prime number. So that's a good indication that we cannot simplify. So our final answer would be negative 41 over 36. And we're leaving our answers as simplified improper fractions. Okay, the last skill we're going to talk about is interpreting negative number statements. Let's take a look at some of these examples. So the first one's a word problem. It says, John ate too many holiday cookies and gained 2.2 kilograms in December. Then he went on a diet and lost 1.5 kilograms in January. Then he lost another 3.7 kilograms in February. John wants to know what the total change in his weight was over these 3 months. Well, obviously, if you're gaining weight, that's going to be a positive. And if you're losing weight, that's going to be a negative. So he gained 2.2, so we're just going to leave that as a positive. Then he lost 1.5, so let's add a negative 1.5. And then he lost another 3.7, so let's add another negative 3.7. So taking a look, do we see any answer choices that look just like this? It does say choose one answer, and I can see that answer choice A looks identical to what I just wrote. Okay, which situation can be represented by the expression negative 2 plus negative 1? So negative 2 means that we're obviously starting below ground. So I can take a look at A, B, and C, and I see that answer choice C says the badger is starting 2 feet above ground. So right away I can eliminate that. So we're starting 2 feet below ground. If I'm adding another negative to it, are we digging further down or are we digging back upwards? Obviously it's a negative. It means you're digging further down. So the correct answer would be answer choice A. Let's take a look at another one. Maya dropped her keys down a storm drain. Her hand was 1 meter above the ground, and the keys fell 10 meters to the floor of the drain. Following equation describes this situation. 1 minus 10 equals negative 9. Well, remember, she's starting, let's say this is the ground, and her hand, let's draw Maya. Sometimes drawing a picture helps. Here's her keys. This right here is that 1 meter. Okay, and then it's going to fall another 9 meters down, or sorry, it's going to fall a total of 10 meters. So 1 meter from up top here and then another 9 here, which means that the negative 9 is where the floor is. So answer choice A says the distance between Maya's hand and the floor of the drain was 10 meters. It can't be that one because they told us they fell 10 meters. The keys fell 9 meters. Well, we know that's not true because it tells us right here that the keys fell 10 meters. So in this case, the answer would be C, none of the above. Negative 9 would represent how far below the ground the floor of the storm drain was. Okay, the correlating pages in your note-taking packets are pages 14 through 17 to the top of the page. And just as a reminder, you can always watch the videos on Khan Academy if you would like to see some additional examples. Please feel free to email myself or Mr. Lab with any questions that you have. Have a great day, everyone.